talk about homework number 3. So I'm going to skip over the first 3 questions because those are just interpretive questions. Those are just subjective questions. How would you solve these? So I'm going to skip over those. I'm going to jump right into the ones where we can maybe definitively tell an answer. So skipping right to section 2, we have this diagram in front of us. We have to start naming some pieces. So the first thing we have to do is identify 2 sets of congruent segments. Now, what that means is we have to, one, identify that we are asking for 2 sets, not just one, so we need 2 sets of answers. Another one, we're dealing with segments here, so we want things that are going to be the same length, but also line segments. And so on the diagram, what we're looking for are tick marks. And so stuff like this. So like the fact that we have 3 and 3 indicate that we have some congruent segments. Here we have 2 sets and 2 sets. That indicates a congruent set of segments. And here's another set of 2 and 2. Now, in truth, all the ones with 2 are the same length, but we're looking for sets of segments, and so that's what we have to answer to. So in terms of identifying these, well, certainly the ones that are in the green, those are going to be congruent because they have 3 tick marks each. Recall that tick marks are actually how you tell on a diagram that things are congruent. So we have EF in this case, segment, using proper terminology, congruent to FG, proper notation I should say, excuse me. The orange set, or the pink set I guess, we have CJ, congruent in this case to JH. And the last one in pink that we have CK, excuse me, congruent to KD. Okay? So even though it asks for 2, I go ahead and put 3. So that way you can kind of match whatever ones you have seen. Now you might point out that on this diagram we have more congruencies. These angles here are congruent to the ones here because they're marked with the same number of arc marks. They work the same way as congruencies, and then we have these as well that are going to be congruent that are marked. But since I asked specifically for congruent segments, then I just want to name segment parts, not angles in this case. Next question asks us about bisectors. Now bisectors are something that cut a single thing in half. And so we're looking at this diagram. Certainly J is going to serve as a bisector because we have congruent pieces to the left and right of J. In the same way, K is going to serve as a bisector because we have congruent segments to the left and right of K. So I'm going to go and get those 2 answers down right away. Oops, I forgot what they were. J and K. Huh, how ironic. So J and K are 2 bisectors. Now you might get tricked into thinking F is a bisector. F isn't a bisector, and the reason why is F does not cut anything in half. It does have something coming from the left and right hand sides that are going to be congruent, but this is not one continuous thing. So this is actually 2 segments that meet at F, and those segments happen to be congruent, but in itself this is not one continuous segment, it's 2 pieces. So F, although it serves as a point of intersection of 2 congruent pieces, F did not cut anything in half because these happen to be separate things, separate segments in this case. That's not the same deal as with J and K, because in the case of J there is 1 segment where J serves as a quote-unquote cutting point. Same thing with CD. You have 1 continuous segment, and you have K that appears to be in the middle. Right? And so that's why these are the only 2 answers. Moving on to the second one, we have to analyze the diagram below. And so here we need 1 set of parallel lines, okay? 1 set of perpendicular segments. So we have to kind of interpret what those things mean. Parallel just means they're going to be running the same direction, same distance apart. We can also note that we're looking for symbols like this. That's what parallel means. And so if we go to our diagram, we do have 1 set of parallels that run right down the middle of the diagram. We can confirm that because of the markings. And so we do have to name those. So on the left-hand side, we have US, parallel in this case to WV. For perpendicular, we're looking for that kind of marking, and we do have that right here. And so we have to name those. We have TU as a segment, perpendicular to TS. Okay. We need 3 sets of congruent constructors. Congruent means they are going to be marked to be the same length. We do have some congruencies here. It looks like we have 1 congruency set there. We have another congruency set on this side. And since they did ask for constructors, we're allowed to use angles. In this case, we're going to have to. So we have a congruency there as well. So marking the purple first, or the pink first, I guess it's kind of pink. We have segments. So we have WV, congruent to Vx. Okay. Actually, let's go to green next. And so on the green, we have Tu congruent to Ts. And then for the last set, these are going to be angles. And so we have angle T that goes to U and ends at S is congruent to another angle set, U going through S, ending at T. Okay? So this asks for 3 sets, so we have to name 3 separate pairs. They all have to be congruent, so they're marked in different ways. There's lots of different directions I would create this diagram. It's not one that I'm going to go through and give you an exact answer because there are so many varieties. But I will point out this. There are some markings that you need to make sure that are in your set of directions, namely these 2 guys here that point to a parallelism. These guys here that point to perpendicularity. And then I would also mention in your diagram, you should mention that this is specifically neither parallel nor perpendicular to the lines they intersect with, and certainly a different distance than WR. So there's lots of variety here, just like the first set of questions, so it's not really worth it to give you an answer. But I can tell you the best way to test this is to, with your directions, create a diagram, and if it matches a diagram that you have or is very, very close to it, with all the markings that I mentioned before, you're probably in really good shape. Okay? Let's move down to this bottom one. Oh, I'm sorry, section 3. So here we have to do some sketching, and now we're combining some words here. Isosceles, meaning, again, these are meanings you should have, or definitions you should have already. Isosceles means that you have 2 sides that are the same. Of course, we're dealing with a trapezoid, and so an isosceles trapezoid, which should look something like that. 2 sides are marked to be the same, with some parallelisms. Scalene means no sides are the same. Of course, we know what a triangle is. And so we just need a triangle in which all 3 sides are different. Okay? And so that is different from that, is different from the third side. Equilateral, equal meaning equal, lateral meaning sides. Of course, we're dealing with a triangle. So we need to draw a triangle in which all 3 sides are the same. Okay? Looking up these pieces, again, interior are angles that appear on the inside. So these are our interior angles, the ones I'm marking now. Exterior angles are angles that appear on the outside of the diagram. So that would be an exterior angle, that would be an exterior angle, and that would be an exterior angle. Okay. Last one, consecutive. The term consecutive means in a row. So if I look at a diagram, say like this, and I have like these angles, consecutive angles are ones that appear in a row, and so like 1 and 2 are consecutive. 2 and 3 are consecutive. 3 and 4 are consecutive. And then 4 and 1 are also consecutive. Okay? So consecutive just means angles that appear in a row in a diagram. And so let's say going around a diagram on the interior sets, we're just looking for the inside. So just some terminology that you guys should probably know already, but if not, make sure you look those up and so you have that knowledge ready to recall. So we have to find the area of the following pictures. So really, you have to do 2 things. One, you have to identify what shape you're looking at, and you can kind of take this to be relatively to scale. The second thing you have to do is to find a formula for this. Now, this is a trapezoid, and so there is a trapezoid area formula. It is as follows. So if you take base 1 plus base 2 divided by 2, then multiply it by the height, you should find the area of this diagram. The bases are the parallel sets, and so we're going to take 4.2, add it to 8.4, divide that by 2, and then multiply it by the height. And so the height in this particular case is the one that runs straight up and down, so this is going to be 3.6. So grabbing our handy calculator, we have 4.2 plus 8.4, divide that thing by 2, then multiply it by 3.6. And we're going to have 22.68. And so their area will be 22.68. Okay, continuing on to the bottom, again we have to do some identification, then we have to find a formula. This shape you should recognize as a kite. The area in this case is going to be diagonal 1 times diagonal 2 over 2. These are formulas that are known. You can certainly just go find this information, and you should at this point. Diagonals from, again, a previous study are the lines that go inside the object and go from corner to corner. And so the diagonal 1 could be this guy. So that's going to be 12. Multiply it by diagonal 2, which in this case is also 12. And then divide the whole thing by 2. 12 times 12 is 144. 144 divided by 2 is equal to 72. So that's going to be the area of that one. So area formulas, again, nothing new to us. This is just going to be some review. But it can certainly give you an idea of what kind of stuff we're going to be looking at in the very near future. Okay. Finally, let's drop down to some algebra. We need to do some solving here and then round to decimal place. And so we can do this on a calculator because we do ultimately just try and do some rounding here. So we take the square root of 40 and we round to 3 decimal places. We end up with 6.3245. The 5 will kick up the 4, and so we're actually looking at 6.325. Square root of 95 is going to be 9.7467, and so again, looks like that's going to round up. So we end up with negative 9.747. Looks like we have some unfinished Pythagorean theorem business here. 4 squared is 16, 8 squared is 64, making that c squared. So this will be 60, 70, looks like 80 will be c squared. So square root both sides. So we have 80 taken as a square root. And so c is going to be approximately equal to 8.944. Well, actually going to be 442. That's not going to round it up, so we'll keep it as it is. So we have now some things we have to add together. So we take the square root of 10, and then we add the square root of 8. We end up with 5.9907. The 7 will kick that number up, so we end up with 5.991. And precision does count here. These are the exact answers that I'm looking for. In number 11, we need to find the slope of the following. Now, none of these are to form, but again, pulling from an equation, y equals mx plus b is what we're looking for. And so we're trying to get the y by itself so we can read the slope. So we had to do a little algebra manipulation. Again, not a huge deal here, just something I know you've done before, just get y by itself. Okay? And so what we're looking to do is get y by itself. So over on the left-hand side, let's first get rid of this positive 3x. We get rid of positive anything by subtracting. And so now we have 2y. On the left-hand side, we have negative 3x plus 10. They're not like terms, so we can't combine them. I'm continuing. Let's now divide everything by 2 to get y by itself on the left. And so we have y is the same as negative 3 over 2x plus 5. So now we have it in form where we can get the slope value. The slope in this case will just be negative 3/2. So that's a template how we're going to solve all of these. To get y by itself, let's first add 4x to both sides. That'll get us one step closer anyway. And so now we have 7y is equal to 4x plus 11. Oops. Let's divide everything by 7 to clear the y value. Okay, so we have 4 over 7x plus 11 over 7. We're not really concerned with the y-intercept at this point. We're just looking for that slope, the number, the coefficient in front of x when it's in slope-intercept form. And so in this case, the slope will be 4/7. Here, again, we're making it a little more complicated. Not a big deal, though. We're still going to get all the y's by itself, so let's start by subtracting 2x on both sides. And so we have negative 8y is the same as, in this case now, negative 12x, because negative 10, take away 2 more, you end up with negative 12, plus 3. Let's divide everything by negative 8, because we have a negative 8 times y, so we get rid of multiplication by dividing. clear out. And so now y is the same as negative 12 divided by negative 8. Two negatives, of course, make a positive. When we take 12 divided by 8, we end up with 1 1/2 or 3/2, depending on how you want to see it. I personally like fractions better than decimals, so we'll just keep it as a decimal. And so the m value in this case will be 3/2. Because now it's in form, now it's in y equals mx plus b form. We can observe that the slope, not erase, we can observe that the slope is just a number that's in front of the x, and that's how we're pulling the slope like that. All right, last problem of this homework set. Let's do some algebra. So we have some simplifying to do first. So it looks like we have to do some distributing. In fact, two sets of distributing. Negative 3 times 4x makes negative 12x. Negative 3 times 3 will make a negative 9. 4 times 6x will give us 24x's. And then 4 1s will just give us 4. Okay, combining some like terms on this side. Negative 12 plus 24, so negative 12x's add 24x's. The net result will just be 12x's. Negative 9 plus 4 would be negative 5, and that's going to be equal to and that's going to be equal to, in this case, just 43. Okay, so now we're just into our algebra steps. Let's add 5 to both sides. So we're left with 12x's is the same thing as 48. Okay, divide both sides by 12, and x in this case is now just going to be 4. Okay, so we have another function-born problem. Here we're told what the x value is, so we're going to substitute that in our x spots. And so the function called f that wants to use negative 3 as an input, now we'll take that x, multiply it by 2, add 1 to it, multiply it by 7, and then subtract 10 at the end. So let's go ahead and do that. Order of operation says do the parentheses first. 2 times negative 3 is negative 6, and then add 1 to it. Negative 6 plus 1 should be negative 5. Negative 7 times negative 5 will be positive 35 because two negatives make a positive. And then we'll subtract 10. 35 subtract 10 makes 25. And so the function called f that wants to use negative 3 as an input is now equal to 25. Last one, get x by itself. So let's start by adding 3 to both sides. That'll get rid of that minus 3. So we're left with just 3x squares. 360 plus 3 would be 363. Okay. Get rid of the times 3 by dividing it. So in this case, x squared is equal to 121. Let's square root both sides. And so we're looking for the square root of 21. What number times itself is equal to 121? There actually is an answer to that. That's 11. But of course, that's going to be both positive and negative 11, because negative times a negative is a positive 121 as well. Okay, so a little bit shorter here because of this last subjective questions, which makes sense after like going through a lot of the work. That we should be able to answer kind of the why questions now, or the how questions, versus just do the skill. And so this is last homework that I expect before you guys are ready to take the test. Now, in addition, there'll be some extra practice as well. But if you're really comfortable with all the homework and the extra practice, you should be very confident for the test as well. Right? So thank you guys for watching. Have a great night.